I'm Qingyi. Thanks, Wendy, for the introduction. And now I'm a research scientist from our AI lab at Autodesk. So today the topic is co-design with AI. So we will introduce the research projects and application and visions from Autodesk and also our research lab. So I will also briefly introduce some of my background. And as Wendy said, I started mechanical engineering at the beginning, and then I feel it's a little bit boring. And then I transferred, or basically went to another school to study architectural design. But because of my training in mechanical engineering, I had a lot of engineering thinking that makes me, when I was designing the architecture, and I started to think about how can we combine this engineering thinking and artistic thinking together. So I started to use a lot of computational tools. And after the bachelor, I went to MIT to study computational design and computer science. While I was at MIT, I also was part of the MIT Media Lab in the Tangible Media Group, where I did many research projects with them in the direction of human-computer interaction. So to summary, while I was at MIT, I was really focusing on the intersection between design, AI, and human-computer interaction, meaning that I want to explore how can AI help human, or how can AI collaborate or interact with the designer to create better design. So that lets me to basically get into Autodesk research to start my research career here. So what is Autodesk research? I think you all know Autodesk. We have many software tools for different industries, but Autodesk research is not making any specific software, but a research institute that has many different groups focusing on different research topics. For example, we have the AI lab doing the research for AI, and we have human-computer interaction lab. We have the AEC Industry Future Lab that is specifically focusing on the application research or the applied research in the AEC domain. We also have robotics lab, simulation, optimization lab, and so on. So each group are actually developing or research on the specific topic, and then the technology developed in the research labs will be transferred to the product team, and eventually that becomes the new feature or new product, and that can be used for you today. For example, the Autodesk Generative design tools are originally from the research lab. So yeah, now we can start to talk about the topic today, which is AI-assisted design. So before we dive into that, we want to ask the first question is like, when nowadays we know the AI technology is like progressing very, very fast, and we have many amazing applications or breakthrough every day almost. For example, you can beat the world-class chess a Go player, and you can have an AI algorithm that generates fake articles or even fake images, or do lots of recognition or robotic tasks. But the first question, like everyone will ask, not only designers, is that like, are we going to be replaced by AI? Before answer this question, I want to dive into the problems or the things we are doing today for designers. So that is design, right? So what is design? Design is actually a very complex behavior, and also that covers a very wide spectrum and also very deep, very deep. Basically, it has a really wide and depth. So the width I was trying to say is when we talk about design, we have painting or artistic design, conceptual art design, to industrial design, to architectural design, to a very engineering IC design. So that requires different spectrum parameters to describe it. For example, on the left-hand side, we becomes more artistic. On the right-hand side, it will be more engineering. And from the left-hand side, it's more creative. From the right-hand side, it is trying to solve for objectives and constraints. And for the left-hand side, you can express more feelings and abstract meanings. And from the right-hand side, you will be serving for a specific user or purpose, and so on and so forth. So when we talk about design, it's really hard to find a optimal way to do it because it's so different in different topics, right? And in terms of depth, let's just talk about AEC. In AEC, we have many processes or iterative process, and it's really complex and involve many different stakeholders and lots of topics, and people have to collaborate, lots of problems need to be solved. So it's really hard to just find like one solution or one AI algorithm that can solve all of these complex issues. So like all the research questions, we also want to know what's the current solution, right? So the current solution is generative design. I think many of you might know generative design is basically we define the problem in using a parametric model, and then we run some optimization process that tries to find all the possible solution or optimal solutions, and then we explore and choose the best solutions. But the limitation of this is that when the user wants to be more involved, or when the user wants to do design by themselves, or they don't want to just pick from the generated results, what are the solutions? And that also goes back to the first question we are asking. How can we apply AI? Are we just gonna use AI to replace us? What if? The answer is, what if we in the future can collaborate, can interact with AI? So that's our that becomes our research question. That becomes our vision to work on AI for design. Sorry. So before we dive into how we do that, let's look at some reference in other industries. So in autonomous driving, people define the levels of automation in different levels. So from the left-hand side, that's no automation from level 0. And from level 5 is, the right-hand side is full automation. The question is the higher level the better? Actually not. For example, if you are just trying to go to the office from your home every day, every morning, probably you don't want to drive at all. But if you are on vacation, you are driving a sports car with your family or friends in a beautiful country yard, and then the driving experience becomes a really enjoyable experience, right? So the answer of this question is actually it depends on the question or the situations or the preference of the user. So when we want to apply AI back to design, and then we also need to define several scenarios such that each scenario can fulfill some specific needs or user preferences. So we define this by into 3 categories. That is based on the level of user control. So the first category is called design automation. That means the AI agent is doing the design for you. And the second level, which has less AI control, you have some user control and AI also do something together. That's called design interaction because AI is doing the design with you. The third level, which means you want to have more control, you want to do the design completely by yourself. You just want the AI agent to provide you some insight or information, and that's called advise you. Among these 3 scenarios, I am mostly interested in the second one, which is how we can work with AI together. So the with you idea. So I will start to talk about how we do this with you ideas by first talking about the research, early days research projects from 2017 to 2019. So the first project we did is called cross-model interactive layout design. So don't need to struggle with the name. So let's just look at the example. So when we are doing floor plan layouts, we usually use, as an architect or as a designer, we usually use sketches. And sometimes we use bubble diagrams. Bubble diagram means we draw the bubble or the circle to represent a room, and draw another circle to represent another room, and draw some edges to represent if they are connected or not, right? So after we draw this bubble diagram or sketches on our sketchbook, and then we scan it, or we do that in Photoshop, and then we move into AutoCAD, Revit, or whatever to draw the final layout design. But it takes really lots of time, because when you want to modify the design, you have to go back to sketch or go back to bubble diagram, and you do that to make a CAD model again and again, right? So the question is, how about we have a translator that tries to understand your sketch or understand your bubble diagrams, and that produce a layout for you, or that understand the layout and produce the bubble diagram or sketch for you, right? So if you have a translator, then you can get go from one representation to another representation very easily without any painful redrawing or modeling process, right? So the technology we use on this project is called GAN, Generative Adversarial Networks. So it was a very popular machine learning or deep learning technique model invented by Ian Goodfellow in 2014. So the idea is we want to train a model that can produce realistic layouts, right? And how can we do that? It's really going to be very difficult if we only have this model to try to produce good layouts. So we start to train another model together. That model is trying to judge if the layout is good or not. So the analogy will be, if I have a bad guy is making lots of fake money, and then the government is always trying to identify if the money is real or fake. And then if they compete with each other, and then eventually both will become very good, and then we will have the real, really good bad guy that produces a lot of fake money, in our case, which is the good layout, right? So the idea of GAN is actually that simple. So when we apply this idea to try to build a translator for our sketch and bubble diagram to the layout, we got this demo prototype. So you can see on the left-hand side, the user is drawing the sketch. And at the bottom middle, you can see the layout is being generated in the real time. And in the middle top, you can see the agent is also trying to understand the meaning of the generated layout here. Where is the bedroom, where is the living room, and so on and so forth. So while you are drawing the sketch, two representations are being translated, right? So I can just keep drawing, keep drawing. At some point, I feel, yeah, maybe that's enough for a sketch. I want to try to modify some idea using a different way, such as bubble diagram. So I can just click switch. And now the model start to let you input the bubble diagram on the left-hand side, and it keeps trying to understand what are you doing right now and produce the layout for you. So in this way, you can just drag the room and change the room type, or scale up or scale down the room, and then you can still see the layout is keep changing. And after that, you can even run some optimization of process to make sure everything goes right or to fulfill specific requirements. So in this way, this model really provides you different ways to guide the machine learning model, and also let the machine learning model understand what you're doing by using these two different representations. But after we done this, we want to do what's the next, right? So you want to ask the question about, okay, now we can do this, what's the next? So the question or the problem of this previous approach is that, okay, the results generated by these models are images or pixelated information, which is not the common representation we're using in design, which is the CAD models or 3D models. So we want to be able to draw some sketches and directly that generates not images, but BIM models or 3D representations or vectors, right? So that's why we started the second project, which is BIM-GAN. So we want to use Sketch to directly produce 3D and VR. This is a project we collaborate with Gensler and NVIDIA. At that time, NVIDIA is trying. Gensler is an architecture firm. They are trying to build the headquarters for NVIDIA, and they already designed the headquarters, but they are struggling with the interior layout because this is a huge headquarters that has to fulfill basically 4,000 people, if I remember correctly. So the layout to putting all the cubicles, the conference room, the functionality rooms are really, really time consuming. It takes several days to complete one version of the layouts. So we are thinking, how can we help this process to improve this process to make it better? And at the same time, we don't want the user to learn some new tools or using some new softwares. We just want them to be able to do the design as they are doing today. So this is their current workflow. So as you might know, usually you will print the empty layout and start to put on the tracing paper and use the marker, different colors to mark different zones. And after that, you will dive into each zone to do the specific design or layout in that zone. So this is the current layout. So how can we use this? This is the current workflow. So how can we use the project or the technology we invented in the previous project and help on this project? So that's why we built this prototype. You can see here, imagine you are holding an iPad using an Apple Pen, and you are basically tracing or putting on the tracing paper and try to lay out the zoning of this complex layout. And you define the different colors as different functional rooms. For example, purple means the conference rooms and green means the cubicle areas. And then after that, you can just dive into each zones to draw the blue lines. The blue lines indicates the corridors or circulation. So by doing this, you can quickly get the layouts very, very, very fast. And the model, the agent, the GAN agent will help you to do the layout based on your request or your intention, which is the blue lines, the circulations. And more than that, we also are able to produce, we also are able to produce the 3D models or BIM models at the same time. For example, I think it's from here. Yeah, so we can directly convert the result from our sketch layout to BIM model with all the families and the things aligned. And also we can do that in VR. So the interesting thing happen right now is that the client can just put on a VR goggle, and then you as an architect can just do the sketch really quickly, and the client can immediately see the design changes or the new ideas being visualized. So this process not only speed up the original layout design process for this huge office complex, but also provides a new way to interact with your client. Right now, they don't have to wait for days or weeks to get the new version. They can directly interact with you, and you can alter the new design idea and show them immediately. So these are just some details. We are able to do this. Previously, we only able to do the image layout output. Right now, we can get VR and 3D output because in this process, in this project, we not only using the GANs to produce the new images, but also trying to train another model that tries to understand what's being produced, and that predicts all the parameters of the items, such as the rooms or orientation and size of the rooms and so on, so that you can use those predicted parameters to reconstruct those 3D objects in Revit or in BIM. But this has some limitations. For example, the reason we can do this is because the objects here are all like modular or like a component. So you have a room or a cubic. What if the design, like a sketch, doesn't have a discrete components? For example, if I draw something like a Zaha Hadid or some complex building design, so this method won't work. So how can we do this? Not just using another prediction model to predict what's being generated, but instead directly ask the model to create the actions of modeling sequence. So that leads to the third project. So due to the time constraint, I will just move forward a little bit faster. So feel free to ask any question if you feel this is not clear during the presentation. So the third project, which is the idea we want to use or train the model directly producing the modeling sequence instead of just producing an image. So you can see on the top row, if we produce an image, and then it's really hard to modify the idea. But if we did in the bottom row, which is that we can have all the modeling sequence or drawing sequence predicted as individual actions, and then we can easily modify all the sequence because they are individual actions or objects. But to do this, train this kind of model is really hard. So usually you have to use reinforcement learning. If you don't know what is reinforcement learning, it's fine. The idea is just like you just have a model that tries to produce all the actions eventually that will reconstruct what you wanted to reconstruct. For example, given a heart shape as an image, you want the model to be able to produce or draw the heart shape using some sequence of actions. So this is really hard to train. But if we think about how humans do it, so usually if you give me an image of a heart shape, and before I draw it, I can think about, okay, I know the heart shape can be decomposed into several strokes. And if I draw this stroke on the left-hand side, it might look like this. And if I draw the stroke on the right-hand side, it might look like that. So I can do this kind of imagination before I really take action, right? So if we train a model that can not only produce the actions, but also imagine what the consequence of this action, then we can make a model that produces these actions and make another model that imagine the consequence of these actions. And then I can draw this imaginary heart shape in my brain, right? And I can compare this imaginary heart shape with this input shape and to verify if I'm doing right or wrong. Yeah. So if we train this model using this pipeline here, then we will be able to train a model that can produce these actions. So we did some simple toy problems that just try to draw this kind of weird characters. And we also did some project that test on this drawing animation characters. And most interestingly is that we also tested on building 3D models. So imagine a person who is modeling the 3D shape here. We have two cuboids here. So you will probably look at your monitor, which potentially has the top view, side view, front view. And you will move your mouse cursor that tries to define some parameters of the top left corner or the bottom right corner of this cuboid. And you click and see if that's correct. And then you do the next one, right? So we can let the model do the same thing by actually let it produce or predict all the actions or parameters of this cuboid, and also ask it to imagine how does it look like from top view, from bottom view, from side view, right? So if we do this, then the model will be able to learn how to build this 3D objects by taking actions, like we are using the modeling commands on the 3D modeling software, and then imagine what can be the consequences at the same time, and then we will be able to learn this task. So now we finish this another project and time to start to ask another question, right? So now we can produce the modeling sequence as an output, but how about the input, right? The input is still maybe just sketches, but is sketches the only way to input, or if the bubble diagram we saw in the first idea is the only way to input? The bubble diagram in the first project is actually the one in the middle, which is not really a bubble diagram. It's more like you already draw the shape of each room and arrange them together. The bubble diagram is actually more abstract on the left-hand side, so which is really just bubbles and edges. So can we train a model that can really take this really abstract idea, such as graphs or charts or tables or something like that, to help you to create a design on the right-hand side? So that becomes our next question. Also, we haven't really analyzed or simulate or verify any of the results generated in our previous projects. And also we haven't explored the next step in, for example, structure design or even construction process. So we also want to expand the process to those later process. So with these two questions, we started the project and published 2 papers this year. So right now I will try to illustrate these 2 projects. So the first project, as we mentioned before, we want to taking the really abstract ideas of the bubble diagram, and that can help us to produce many layout design as an output. So the user can just draw the bubble diagram really quick and modify the edges and nodes and or the connectivities, and then we will be able to output all these layouts on the right-hand side. So this is accepted by ECCB, which is one of the top computer vision conferences. If you are interested in this paper, the code and papers and dataset are all open source, so you can just search the GitHub to find it, and you will be able to download and play with it. So what we did in this model or in this paper is that we proposed a new model that still used the idea of GANs. We trained 2 models competing each other. One is trying to produce a better model, a better layout. The other one is to verify if this layout is real or fake. But what we did more is that the input of this model is not only a given image, but a graph that represents the bubble diagram. So the bubble diagram will be represented as a graph here, and then this model will take in this graph and try to consider all the relationship between the adjacent rooms, and also consider the general requirements of the whole relationships, and then try to produce the room shape for each node. So for example, the yellow one is bedroom, and then the pink one is the dining living area, and the gray is the bathroom spaces. So with this input, and then the model will be able to produce different layouts by considering these relationships. And then there's another model, which is the discriminator, which is actually trying to learn to distinguish the real floor plans and those generated floor plans. And by doing this new pipeline, train this model, we will be able to have the model being able to take in the bubble diagram and produce different good layouts. So how can we train these models? Usually, I forgot to mention at the beginning, when you want to train a machine learning model, you usually need a data set, which contains lots of examples of those layouts. So we acquired this data set from a Japanese company called Lifo Home. They provide this layout data set for research purpose. So if you are doing research, you can request to have this access to basically send the request to the Lifo company. We got around like 100K layouts to be able to train this model. So to verify the results, we have different, basically different metrics to verify the result. The first one is realism. So as you can see, the most left column is the input graph, and it's the bubble diagram. And the right-hand side, the most right column, is the ground truth, which means the real design layout from architects. And you can see in each column, these are different models. And then this column is our result. You can see actually this column is the one that is closest to the real design, right? Obviously. But this is just, visually evaluated. But how can we convince people with more scientific numbers, right? So we also did a user test. We had two groups of people. One is students, the other one is architects. And we randomly pop different pairs of layouts that represents the layouts generated either from different models or from the real design. So we got these two metrics or two tables as a result. So you can see the blue means it's winning, the red means it's losing. So you can see, of course, the ground truth, the real designs are still winning over all the other methods or models. But ours is the one that only lose to ground truth, which means it's the second best in both groups. We also want to verify not just the realism, but also the diversity. So diversity means given one bubble diagram, we want to create many, many different layouts. So when you can see here, given this bubble diagram, this is the sample design from the real designer. And each row represents the result generated from different models. And you can see the second row, which generates kind of okay layouts, but you can see they are, very similar to each other. But in the last row, which is our model, you can see we not only be able to create valid layouts, but also each of them are actually pretty different from each other. That creates this diversity we want. The last thing is we want to measure the compatibility. What's the compatibility? Is basically just when we want to create the layout based on the bubble diagram, after we got those layouts, we want to verify if this layout is actually still following the input bubble diagram, right? So these numbers are calculated by comparing the relationship in the generated layout and the input bubble diagram. We can see ours are the second best compared to this method. So the reason we are the second best is we sacrifice some compatibility or some accuracy to gain the diversity. So we really want to have very, very different results, and we want to be able to create as many as we want. So that means this we need to do a little bit of sacrifice, but still this is a worse trade-off. So nothing is better than showing a demo. So in this demo, we implement the House-GAN here. The left-hand side user can just keep drawing the bubble diagram. And the right-hand side, you can see different results being generated. So the user can keep adding the nodes and make some modifications, and after that you can just keep exploring and keep generate to compare those generated results. And at that one time you just keep generating, and maybe at some time you feel, oh, I got a really good result like here, and then yeah, maybe the first one is the best, and then you stop. So this just demonstrates the idea where user can exploring the layout options that using the bubble diagram and to get this concept on the right hand side. And then after that, you can take this to further modify the details of the floor plan layout. So the next project is how we can extend this to solve more structural engineering and construction related problems. And this is also really important because if you know, I think 11% of the total carbon emissions are basically from the construction process. So if we can make the construction more lightweighted or use less material, and that will reduce the emission a lot. And also design exploration is important, as we show in these previous projects. But design optimization is also critical. As you can see here, we can solve this cost issue or emission reduction issue, right? So this is the second paper we published this year, which is trying to train a model that can produce the best cross-section design for the structural system. So usually the structural designers, they once the architects finish the building, and then they will propose some skeleton, and then decide the cross-sections of each structural members in this skeleton. And then they will run some simulation using, for example, finite element analysis tools. And then based on the result from the simulation, and then we can modify the cross-section size design or even modify the skeleton as well. So the project or the paper here, we are focusing on this part. How can we do a better or automatically generate a best structural cross-section design that fulfills all the simulation requirements? So we need to consider all these real structural loadings and structural elements, and also need to be able to run the real simulations. However, the problem is running real simulation is so slow. So even if you have a model that can predict really nice size design for the cross-section, you still have to run through the simulation software to verify it, which takes really long time. So how can, if that's the case, when you want to train millions of examples using the machine learning technique, and then this will take, you know, infinity time, like a year or something like that, to train a model. So we don't want that to happen. So what can we do here? If you think about all the tricks we have been using in the past several projects, you can imagine now we can train another model that tries to mimic what the structural simulation is doing. Basically, we train a model that tries to predict the result from the simulation process. And if that's the case, then we don't need to go through the real simulation tool. We can just let these two models to compete or to collaborate with each other. This model is trying to produce many good cross-section designs, and this model is trying to verify the result and tell this model if anything goes wrong, right? So by doing this, we will be able to, let's just skip some details, sorry. We will be able to produce some very convincing structural elements or structural core design ideas. And we will also, because we are training the second model, which is replacing the traditional simulation tool, that also largely reduce the simulation time from seconds or minutes, even hours, to several milliseconds. And we will also be able to train this prediction model that predicts really valid size design. That's based on our evaluation. Sometimes it can do even better than structural engineers within a limited time. So most interestingly, we can also basically, if we compare with the current optimization methods, it takes less than 100 milliseconds to generate a really valid structural design that beats the results generated by optimization process, which takes hours or days. So finally, I will spend maybe 2-3 minutes to talk about the research vision. As always, when we finish some projects or research ideas, and we always want to ask what's next, right? So the first thing is, when we want to think about the vision, we need to also go back to the problems we are dealing with, which is design. So if we think about those spectrums I used to describe different type of design, and you can see from the left-hand side, it's something human really good at. And from the right-hand side, it's something probably AI or computational tools are good at. So when we think about how human and AI can collaborate with each other and interact with each other, maybe we need to dive into more about what each other can do the best, right? So really, this is a guideline for us to move on, because when we want to think about what's next, we want to make sure human designers are still feeling good, that their creativity can be inputted to the design, not only just taking the result from the AI model. As at the same time, we also want to make sure the design is perfect, is efficient, is optimal, right? So the first general vision is we want to be able to push the boundary of machine learning by thinking about what's the next problem to solve. Instead of just thinking about, oh, okay, these are the state-of-the-art machine learning algorithms, how can we use that to do something cool? We want to reverse this thinking, right? So we want to think about what we want to achieve, and then that will actually drive us to push the boundary of machine learning. So we want to have this reverse thinking instead of just taking what is there on the shelf. And the second one, which is also important, is the representations. So as you know, there are many other companies or industry, for example, Google, Facebook, Microsoft, they are doing lots of machine learning research. But most of the representation they are using are images, videos, or language or voice. So those representations are not directly the representation we use for design, right? So the design, in the design process or the design field, we use solid models, or we use program or procedurals to represent the design. And we also use sketch or high-level abstract representation to represent our ideas. So those are actually really the important representation that we need to be able to use a machine learning model to understand, to read, and to train. So we start to think about the representations more, and recently we also released a data set called Autodesk Fusion 360 dataset that contains many solid models created by Fusion 360. And also it comes with this modeling sequence. For example, we can see this one is probably created by some sketch and extrude, and another sketch of the circle and extrude to make a cut. So if we can have this pair of information, and we can probably ask the model really to learn how we can provide by given some idea or constraints or goals, how can we use this modeling sequence to create an object that fulfill that requirements, right? So this data set is open source, and you can download and play with it. So this really opens the door to explore what can we do in those representations that are often used by designers. Okay, so to summarize, So today I introduced a little bit about myself and Autodesk research, and I introduced the idea of AI assisted design, and specifically I really like the idea of the WISDU idea, which is design interaction. And I went through several projects we did in the past several years, including BIM-GAN and House-GAN, and also this structural prediction model this year. And I also show some research visions of what we want to do or what we care in the future. So right now, I'd love to open the floor to take any questions. But if you don't have time to ask your question, or if you think about any question later, feel free to send us emails, and I will try to respond to that. Thank you.
Thank you, Qingyi, for your very inspiring sharing about co-design with AI. I think from your talk, we know it's important to apply AI or machine learning in the future of architecture. For example, we know the technologies could provide guidance to help architects, engineers, or designers to choose the most practical and constructible design. And we hope to see more examples, more cases in the future. I have received some questions from the audience. Maybe I ask the first question first. So who inspires you to be a research scientist?
Wow, that's a really hard question. So as you can see, my journey, I haven't really done the same thing for more than 5 years. Every several years, I will start to think about, am I doing right? Am I doing really the things I want to do? So all these things guide me to the next journey or the next exploration. So right now, I'm doing AI research for Autodesk, but maybe after several years, I will change my mind. But the point I want to make here is that you always want to understand yourself and understand what are you really want to do. Some people really like to dive into one thing and just focus on that. And some people want to explore many different ideas and topics. It really depends on the person, but there's no right answer. So I think the answer to me to this question is just keep asking yourself, keep exploring yourself, and be honest to yourself.
Okay, so how did you get into your career? This is a question raised by a university student in Hong Kong.
Yeah. So I went to MIT, and I do research in different research organizations, including Media Lab, and that lets me to know many people who either are researchers, professors, or work in the industry. And I got connected with some people at Autodesk Research, and then I did some internship with them, and that actually let me get into Autodesk Research after I graduate. So internship is important.
Okay, so what advice will you give for someone who is new to the industry? For example, who wants to work in the AI research or in the BIM industry?
Yeah, so I think in many people or many companies or even schools, they in the AEC field, they start to think about or explore AI. But as I stated in last few slides, the important things is not try to just apply the state-of-the-art algorithm and see what you can do with it, or just download something from GitHub and just apply it, but really try to ask, what are you trying to solve? What is the problem, or what is the data set you have, and what is the problem you want to solve, and can we do something with it? Instead of just using the existing technology and try to make a use of it. So I think that would be my best suggestion.
Okay, and I've received a new question about what is your view on the prospects of AI? Why it cannot reach the level of human intelligence?
So my view of AI is actually to collaborate with it instead of making it really become super smart or actually can do everything. So many researchers in the AI fields are trying to just produce the better and better AI that can eventually uh, uh, basically pass the singularity point, and then we will have general intelligence. But my view or my goal of that is not like that. My view is, or my goal is to make AI be able to augment human creativity or allow the human to uh, express their thoughts and creativities without being constrained by the limitation or constraints. So usually, for example, let me ask you a question like, if you are asked to design, let's say, a house layout, but you are very limited in terms of space and so on and so forth, and then you have to be very cautious about every single centimeter you put a line or something like that. So then your creativity is actually really limited. So how about you have a tool that allows you to really express your thoughts, even with a very tight constraints, and then you will still be able to solve it with a satisfying result. Then that would be great, right? So that's my goal of research of using AI.
Okay. And another question is, AI is very difficult in simulating professional architects, structural and building service engineer knowledge to comply with local building regulations. So do you have any advice on this?
Yeah,
For
so as you
example,
can
in
see,
Hong Kong, the building regulations may be different from in the
yes,
US.
yes, yes, totally. So as you can see, the structural project we showed in the last few slides, we already are able to consider some building codes in California. So the next question is basically how we can make the model that are able to take in different building codes as an input, not a given, right? So you are able to give some designs that you want to produce a good structure, but you also want to give some building codes or regulations or rules that the model needs to follow as an input, so that you will be able to produce the design based on different building codes as an input. So that will be the next research project or question potentially. But that also requires a lot of work, and also it's not guaranteed to be done in a short time. But that definitely is an important next step.
Okay. So would you like to give some special advice on skills that aspiring AI enthusiasts who shall acquire before entering the industry?
I think if I understand the question correctly, I guess if you want, so there are two ways to interpret this question. So one is you are interested in AI, and then you want to apply AI to the AEC industry, or you already in the AEC industry and you are interested in AI and how want to apply this to the industry. But I think both questions are has similar answer to me, is that uh, don't don't satisfy don't be satisfied with like running an existing model. So you can see many people are just running existing models, but to more think about what cannot be done, and also think about how to generalize the problem, and also how to think about how to. So another uh, sorry, the other point I think maybe is even more important, I just thought about it, is to think about the data set you have or how we can acquire more data. So that is even also a challenging problem here at Autodesk, because we don't have all the designs or all the engineering documentations for all the structural designs or all the building designs. We have to collaborate. For example, you can see we have to work with the Japanese real estate company to get their data set. And then with a new data set, that will give you the power to explore or solve new questions. So how can you get a new data set is definitely an important question to ask, instead of just trying to have new ways to solve things or try to use a better model to solve things better. But focusing on, can you get a better data set, will be a really, really valuable thing.
Mhm. So, for example, if I'm a student that will be graduated soon, so should they acquire programming skills, or, for example, like Python or other skills that you advise?
Yeah, so I think really not everyone has to use AI. So not everyone has to get into AI research, but I believe in the future everyone will use some kind of AI assisted tool. But that doesn't mean that you have to learn a very hands-on AI skill or very deep AI knowledge. That doesn't mean that. Also, same as programming. So some people are, happy with Revit and AutoCAD. Some people go a little bit deeper into Dynamo. Some people go even deeper into coding, such as Python. But for each route, you are making a choice. I think I usually make an analogy like you are playing some kind of RPG games, and you are trying to allocate your skill points. But everyone has a limited time and skill points can be allocated. So you need to make the decision of what is the best route or skill tree you want to grow by yourself. No one can grow everything, right? So for example, I really like architectural design, but I couldn't have time in the past several years to do design because I focused my time in computational design, AI, and so on. So as you, so you don't need to be able to learn everything, but just try to understand what does that mean, how can you do, and make the decision by yourself.
Okay, so any thoughts to apply the technique to lay out MEP plan in building?
So
Yeah.
as you can see, MEP requires even more rules, regulations, and constraints.
Mm-hmm.
So that means there's really less space to express your design ideas of that. So those becomes more likely a optimization problem or something you want the computer to solve for you. So as I stated, the three categories, for you, with you, and advise you. I think MEP belongs to a category of more to the for you idea. So that means you can use methods such as generative design. It doesn't need to be AI or machine learning. You can use generative design that optimize the MEP design. Or you can use reinforcement learning such that it is actually always trying to create or fulfill some optimal rewards that optimize your MEP design. So I think these two directions are the I think the early or easy solution we can think of. But to be honest, I haven't really worked on this problem yet. But anybody, if they work on this problem, and they probably will find some other answers than mine. Yeah.
Okay. And another question is, instead of applying only to AI-assisted design, how much changes will be needed to turn this into an AI-assisted design validator?
Validator.
Design validator. I think
Oh,
it's
validator.
validate.
Yeah. So validation is usually easier than generation. So we can train many classification model or prediction model that can verify the design. So many of the existing tools, such as CNNs or graph neural networks, uh, can be really helpful to do this validation task. For example, in our structure paper, I mentioned we trained two models. One is to produce the structural design, and the other one is trying to do structural analysis, right? So structural analysis is kind of one way to validate design. You do the finite element analysis, and instead of using the real simulation software, you use a model to do so. So I think in general, we can come up with many ways to do validation, or in general, it's easier than generation.
Okay. And can AI recognize our existing DWG drawings as they have many information there that human can understand, and the AI can update it to a 3D rapid model?
Yeah, so definitely that's an important and interesting question or problem, but that's also a chicken and egg problem. So we want the model to be able to understand what is in the CAD drawings, and that means we need more CAD drawings with the instructions or labels to be able to train the model to understand it. So if we can have a really big data set that has many different CAD drawings and with all the label being properly put on those drawings, and then potentially we can train a model to understand it. And then later on, once it's being understood, and then potentially we can produce Revit models or 3D components from it. So that's usually people will ask, like, can we understand the CAD drawing? But I will ask, can you find a data set for me so that I can train a model for you that can understand the CAD drawing? So, but honestly, this is not the only answer, because in the machine learning research field, we have other methods such as unsupervised learning. That means you don't have to have a labeled or paired data set. The model can potentially learn by itself to understand the drawing. But those techniques are relatively not as mature as the labeled way, a supervised way to train it. But I think probably in the near future, and we can try to train the model with less data or even no data.
Okay. And as AI can compose articles and songs, do you think the AI can design on their own? If yes, when?
So as I mentioned, design has a really wide definition, right? So if we want the AI be able to design IC chips, and then we can already do so, because it's mostly more like a optimization process, and then it can just train the model and or just use the optimization process to do so. But if you want the AI to be able to create artistic drawings or even new architectural buildings with some good styles or things like that, it's still far away. And to be honest, I don't want to do that, because I believe the real interesting design is still going to be created by human, and we want human to be able to express their thoughts and creativity to create design, and AI is just helping human. So that's my belief, but I believe other folks might have different thoughts, but I'm not against that. But this is what I want to focus on. Yeah.
Okay. And is there any AI application? Sorry, okay. Is there any AI application to generate schematic diagrams from MEP BIM models?
I don't know if there's any existing models that can do this task. I think that's still in the early days. Maybe someone can do on this project and then publish a paper, and then we will have a solution.
Okay. And also, okay. Do you think AI or machine learning will accelerate adoption of BIM and digital twin? I think we heard a lot about digital twin nowadays, and do you think that will accelerate it?
Yeah, I believe so. For example, if there's an AI model that can observe the construction site and directly grab the information and convert that into the model or the digital twins system. Or if the AI model can just understand the BIM models from your drawings, and then you will be have a more painless adaptation instead of spending a lot of labor time to convert something from CAD to BIM, or spending a lot of time to take laser scanning and convert that to a digital twin model, or so on and so forth. So I believe so, and that fundamentally will be more convenient for the users. But I think more critically is like the users still need to adapt the thoughts and the way they think about AEC projects. That's more important for the adaptation rather than the efficiency or tools they are using.
Yeah. Is there any internship opportunities for university students in your?
Yeah, so we are constantly hiring interns across the whole Autodesk research, even across Autodesk every year. So you can just go to the website, and you will be able to find the internship hiring post, or you can just email the researchers or the research groups that you are interested in, and then we will be able to evaluate the candidate and get back to them.
Okay, and for machine learning-based design and AI-assisted design, what are the major technology trends or future aspects that you want to share with us?
The major technologies, trends, applications, I think is something I mentioned in the slides. First of all, representations. We want more AI algorithms that can understand the representations used in the design field, such as solid modeling, procedural modeling, and also even abstract representations such as sketches, bubble diagrams. We want more machine learning algorithms to be able to do so. And interestingly, in the past several years, I mean 1 or 2 years, the AI research field start to get more interested in 3D in general. So hopefully in the future, or in the next 2 years, we will have more and more related AI technologies and applications.
Okay, and last question. Have you read any books that helped you develop your career?
Really hard questions. So it's really
question, right? Yeah.
It's really hard because it's really hard to say which one is the trigger for you. But I have several in mind. So I think about 10 years ago, I bought a book published by, I think, Japanese Architect Association or something like that. It's AI and algorithmic, I think it's algorithmic design. Basically, the title, I think, is algorithmic design. I think it's published by some published by some architectural research association in Japan. I can find the title of the book, but that book listed many computational design methods and examples, and also touched a little bit about also AI optimization and so on and so forth. That really, let me understand the current spectrum or landscape of how people apply those advanced technologies in design field about 10 years ago. So that may be one of the book that inspired me. Another one is not a book, is a course at MIT. So it's called Artificial Intelligence 6034, taught by Professor Patrick Winson, who passed away 2 years ago. But that lectures you have all the recording from YouTube and also MIT Open Course website. So that is not a lecture talking about the cutting edge machine learning, deep learning AI, but a lecture talking about how AI is invented and evolved in the past several decades. And that really inspired me a lot to be able to go through this journey with a lot of uh, inspiring thoughts leaders in the past several decades, and I think that course is one of the trigger for me to do AI research for design.
Okay. Thanks so much, Chingy, for your valuable time and sharing today.